Combinations today. We're going to spend one day on combinations, which will tell you whether perms or coms is harder. Definition: a selection of objects where order doesn't matter. Example we talked about when we started the unit, hands of cards. Doesn't matter what hands you have in your card, how physically you arrange them, it's still the same poker hand. What about picking a team? Yes to what question? Doesn't matter. So if I wanted to pick 6 people to be on my volleyball team, does it matter which person I pick first? Why? Okay, what if I'm picking for my dodgeball team? It doesn't matter. It's the same 6 team, whether I pick Simon first or I pick John first. It's still the same 6 people playing. I always get chosen last too. Me too. Yeah. NCR, going straight to the formula. NCR, we'll often call this N choose R. That's why we tend to use pick for P and choose for C. So N choose R is N factorial divided by N minus R factorial. What do you notice so far? It's the same. The only thing that's different is there's an extra R factorial on the bottom.
So that's how we set it apart from the National Public Radio.
Correct. So N choose R is N factorial divided by N minus R factorial times R factorial. Do you need to memorize it, or is it on your formula sheet? It is on your formula. This is it. This is the last formula that you need to know that's on that sheet. Where do you find it on your calc? Math. And you put it in the same way that you put in the P formula. So you put the N first, then choose NCR, then put in the R.
On the new operating system, it's kind of different.
So read it out. How is it?
Similar to with the NPR formula. It's
Cool.
actually got the subscripts on it. Also, there's a shortcut, alpha, window.
Nice.
This menu shows up.
Good job. With a partner, calculate A through F. On your calc, yep. Eight choose 5.
56.
That sounds confirmed at the same time. 10 choose 3.
20.
7 choose 3.
35.
7 choose 4.
35.
Ooh, let's just pause there for a second. Make a note of these two being the exact same value. Not coincidence. Which is going to lead us to our first rule that says N choose R is equal to something something. So what's the pattern between these? Why are they both 35?
Because the calculator says so.
Yes, but there's a reason the calculator says so. There's some kind of connection between them. So they both have the same N. That's important. Something else. Sorry? True, because they have to be, yes.
Like they're all below the value.
So is every 7 choose something equal to 35? Okay, so let's just try 7 choose 2. $21. Okay, so that's not 35. So if you take the 2 R values and add them together, what do you get? 7. So when the 2 R values equal N, those 2 will always be equal. We call that NCR equals NC, N minus R. So 7C2 that we just figured out would be the same as 7C. You just have to figure out what do you add to 2 to get 7? 5. So check it out on your calc. A 7C5 should be the same as a 7C2. 7C1 will be the same as 7C. 6. That'll work with any kind of n value. If I gave you, for example, 8C5, you also know 8C3. If I gave you 10C3, you also know 10C7. Okay, so that's our first rule we need to know. Going on, 7C7? Why? But why, mathematically?
Because the calc said so.
Because there's a 0 in the
Yeah, and think about what do n and r represent. So go back to our perm formula, because they're the same thing. What was n? What did it represent? Number of things, number of objects. What did r represent? Number of ways or number that we want to arrange. Now it's the number of objects and the number we want to choose. So if we have 7 objects and we want to choose all 7, how many ways can we do that? 1. What if I had 5 objects and wanted to choose all 5? 1. What if I had 100 objects and wanted to choose all 100? Still going to be 1. So our second rule, an NCN is always equal to 1. What about 9C0? Why?
Because the calc said so.
There's only one way to take none of them. So our third rule for combinations is an NC0 is always equal to 1. So standard kind of questions. Let's go to our paper. So when you first read these questions, they kind of read like permutation questions. So you always need to keep in your head order or no order. Order or no order. Go ahead and highlight or circle the key words. What did you circle or highlight? 5. 3 are chosen. Dance committee, or even just the word committee. It really doesn't matter if it's grad committee, dance committee, math committee. It doesn't matter. It's a committee.
Does the word dance matter?
Dance, not so much. No.
I guess it depends on who you are.
Part A, different committees. Part B.
Jack.
Oh, Jack is back. So Jack isn't necessarily important, but what is important about him? Chairperson. And then there's another keyword, combination. So if they're using the word combination, it probably has something to do with combinations. Committees are combinations. So how many different committees are possible? You just need to figure out your N and your R. How many people do we have? And how many of them do we want to choose? 3. That's it, NC3. Now let's say this was a non-calculator question. How would you do this without your calc? Well, you go back to the formula. What's the n choose r formula? N factorial on the top, which is 5. 5 minus 3 factorial times 3 factorial. Brackets come first, so I've got a 5 factorial on the top, a 2 factorial, and a 3 factorial. You've memorized these ones. 5 factorial is. 2 factorial is. 3 factorial is. 10, 10. Okay, so if it happens to be a non-calc, it's just a straight up formula, simplified kind of question. Here's with restrictions. So we're adding our first restriction with a combination. Stupid Jack. Well, what we do when there's a restriction is we just choose them separately. I'm going to choose Jack first, then I'm going to choose the remaining committee members. There is one Jack, and I need him. How many people are left?
1.
I started with 5. How many are now left? 4. And how many more committee members do I need? 2. So this represents picking Jack. And this is the other 2 members. Do I multiply these or do I add them? Division wasn't an option. Multiplication or add. What's the word that I taught you that always means add? Or. What means multiply is and. So you need to ask yourself, do I need Jack and 2 other committee members? Or do I need Jack or 2 other committee members? And means it's a multiplication. Do not use your calculator for a 1C1. We just memorized NCN. Doesn't matter what N is as long as it's the same as R. What's an NCN? It's going to be 1. Then a 4C2. Let's do it the long way just to practice. On the top is going to be 4 factorial. On the bottom is going to be 4 minus 2, and let's do that right away. What's 4 minus 2? 2 factorial, and then another 2 factorial. 4 factorial is 24. 2 factorial is on the bottom, 2 times 2. And 24 minus 4, 6. This is why we can't simplify factorial. So a 2 factorial times a 2 factorial is not a 4 factorial. If that was true, all of this would be equal to 1, and it's not. It's equal to 6. So you're never going to combine factorials in here. You're just going to multiply them out and simplify. You can't really see that. There we go. What the heck? Aren't picking committee members a perm? Because we did questions with committee members with a perm. What's going on? What kind of questions did we do with committees and perms?
All of them?
Names, yes. More specific. Cole, pay attention, please. Order, so when does the order matter and when does the order not matter? It's specifically with committees. When does it say so? This is painful. It's when you're picking specific committee members, so specific positions on a committee. So you're picking a chairperson, then you're picking a vice chairperson, then you're picking a treasurer, then you're picking a secretary. That is a perm. Sorry? No. If you're just picking general committee members, that's a combination. Just look back at example number 2, because it was really our first comm question. Did I start out with blanks? No, blanks is for the FCP. What does FCP stand for? And that is for permutation. So you may want to make yourself a note on here, no blanks. Rarely do comms start with blanks. They start with the formula. If you're starting to put blanks, then you're starting to do a perm because you're putting positions with the blanks. You're putting one after the other after the other. That's a perm technique. Okay, let's do another committee question. Circle or highlight the most important words. Somebody's already ready. Committee, definitely important. 5, definitely important. 8 choices is important. Jack is back. And what's important with Jack? Refuse together. So we already did that with permutations. Let's back up. How do we do when people refuse to sit together, be behind each other? What did we do with a perm? We did no restrictions. Minus together had to equal not together. It doesn't work that way with combinations. There are 3 possibilities if Jack and Jill don't want to work together. We could pick Jack and say bye-bye Jill. We could pick Jill and say screw off Jack. Or we could pick neither. We could be like, forget it, you guys are trouble, we're not going to have you. Refusing to be together will always be 3 cases. The first person, not the second. The second person, not the first. Neither one of them. Okay, so let's set up our cases. This is notation that makes sense in my head. If it doesn't make sense in yours, don't write it down. I put Jack with a check mark, and I put Jill with an X. In my head, that's picking Jack, not picking Jill. If you need words, use words. If you need a different notation, use a different notation. I'll figure that out in a second, but I just want to set up the cases first. What's the second case? So Jill, yes. Jack, exactly. What's the third case? When people don't want to be together, there's always going to be 3 cases, assuming there's 2 people. So you can have one, not the other, the second person, not the first, or you're just like, forget it, we're not having either of you. For visual people, sometimes this trick is going to help, so I'm going to do it in a different color because you don't need to write it. Just going back to the question, we have Jack, we have Jill. How many other people do we have? 6. So I'm just going to make a note. We have Jack, we have Jill, we have 6 other people. If I need to pick Jack, there is 1 Jack, and how many of him do I need? 1. So I've already picked Jack. I can't pick Jill. How many people do I have left to pick from? Can't pick Jack. I've already picked Jack. Can't pick Jill. How many people do I have left to pick from? 6. How many more people do I need to pick? 4. That's why sometimes when you write it out like this, your brain sees better that there's 6 left. Am I going to multiply these or add them, and how do I know?
Multiply.
Why? Do I need Jack and the 4 other people, or Jack or the 4 other people? So I'm going to multiply. And I'll figure out what those are in a second. I'm just going to set up the cases first. Jill, there's 1 Jill, and I need her. So I've picked Jill. I can't pick Jack. How many other people are left? How many more people do I need? Multiply them or add them. So you notice these 2 cases are exactly the same because we're picking 1 person and not another person. This one's going to be a little bit different. Can't pick Jack, can't pick Jill. How many people do I have to choose from? 6. How many positions do I need to fill? 5, because I haven't filled any yet. Don't calculate the 1C1s. What is 1C1 equal to? So just ignore it, forget it's there. Let's do this one on our calc. So figure out 4C4 and then 4C5. Thank you. 6C4 and a 6C5. That was fast. Hearing confirmation on that? What do I do with these 3 numbers? Why? Because it's case 1, committee 1, or committee 2, or committee 3. So we're going to add them together. Please don't use your calculator. 36. Make yourself a note. This is when people refuse to be together, because it's quite different than what we did with perms. What would we do if Jack and Jill had to be together? So there would be 2 possibilities. What would the 2 possibilities be? Jack and Jill, which is the same because order doesn't matter, or neither. How would we do Jack and Jill if they both need to be on the committee? So we could do a 1C1, a 1C1 to represent Jack and Jill, or we could put them together and say 2C2, whichever way your brain works. How many people would be left if we took both Jack and Jill? 6. How many committee members would we still need? 3. Questions so far? So this is the exam story I've been waiting to tell you all semester. 2 years ago, marking provincial exams. Now, as I've told you before, I should pause. It's not necessarily your provincial exam because it's all